continuing in chapter 7, section 4, on confidence intervals for standard deviation and variance. So in addition to, not only are we going to be using a new distribution, the chi-squared distribution, the way that we go about forming our confidence interval is going to be a little bit different, right? Not only is the equation itself or the formula itself going to be different, but this sort of the overall structure of it, or the way that we can go about thinking of it, is distinct. So here we don't have one centralized point, and then we add a little bit and we subtract a little bit, because the chi-squared distribution is skewed, right? So it is not symmetric. So we're not going to have this principle of finding the margin of error and adding and subtracting. Okay, so here we just have to memorize our chi-squared, how it looks, the formula for our confidence interval, all at once. It's going to be n minus 1 times s squared. So remember, that's our variance for the sample. And then we're going to be dividing this by chi-squared subscript right. And I'm going to go ahead and rewrite this in just a minute with the notation that I use, just because, I don't know, for me it's helpful. That's why I use it. It's because I like to think of it in that particular way. And so, maybe that'll make sense to you. Okay, there's chi-squared left. Okay, so one thing to mention right here is, I'll stop right here and say this: if you memorize the book's notation and this makes sense to you, you find the chi-squared left because it's the one on the left hand side, and the chi-squared right is the one on the right hand side, and you made sure that it was correct, the right hand and the left hand number, this one was larger than this one, then that's fine. Then you just have to memorize this formula as, oh, when I'm dividing, then I got to switch them up. Left is over here, right is over here, but in the formula they switch around. Okay. Or if this notation you don't like it, or if you want to use my notation, it's not mine. I didn't make it up. It's the way I was taught. Okay. Here I would say that this one, remember the one on the right, since the area is to the right, that's chi-squared alpha over 2. Okay, and that's the lower bound still. Okay, and then instead of saying chi-squared subscript left, we're still going to have n minus 1 times s squared in the top. Notice that's the same in both of these. And instead of saying chi-squared subscript left, we'll say chi-squared subscript 1 minus alpha over 2. Okay, so since alpha is going to be small, remember that's our chance of the parameter for the whole population not being in our confidence interval. That's alpha, right? Here, alpha over 2 is going to be a small decimal value, and 1 minus alpha over 2 is going to be a large decimal value. Then when I'm writing it into this formula, the one with the small decimal value is first, and the one with the larger decimal value is second. And that, for me, that makes sense, because that's the order that they should go in. All right, so that's why I'll write it usually like this, the second way. Okay. If you write it like this and you get it correct, perfect. Then I'll figure it out. Okay, but I'm just telling you so that you can figure it out. What I'm doing, I'm going to stick with this to just stay consistent. All right. Oh, and also remember for our chi-squared value, we have to use our degrees of freedom. I think I mentioned this before. I don't think I ever wrote it down. It's that the degrees of freedom is going to be n minus 1. Okay. All right, and then for that's variance. So sigma squared is variance. All right. For standard deviation, it's actually kind of nice. We get both these at the same time, essentially, because remember the relation between sigma and sigma squared? Yes, you do. You're looking right at it. Sigma is the square root of sigma squared. So to get our confidence interval for the standard deviation, we're going to take the one that we form for the variance. Even if we don't want this one, we have to do that first. And then just take the square root on both sides. So on this side, it's going to be the square root of the whole thing, n minus 1 times s squared, all divided by chi squared subscript alpha over 2. Okay, and then on this side here, we have basically the same looking structure, n minus 1, s squared, all divided by a chi squared. What is this chi squared? It's the large decimal, 1 minus alpha over 2. Okay. All right, so let's do a quick example in the next video.